Lesson 6.2 today, we're talking about relating transformations and similarity. So, we talked about transformations back in a previous chapter. We talked about rotations, talked about reflections, we talked about translations where we slide something left to right and then up or down. We also talked about compositions where you do more than one thing, and a very special composition called a glide reflection. Okay, but the main thing with all those transformations was that the original and the new thing were always congruent to each other. So with these, they're not going to be congruent, they're going to be similar instead. Okay, so this is what's called a dilation. Okay, a dilation is a transformation where the angle measurements stay the same, but the sides don't have to. Okay, so a dilation, angle measurements stay the same. The sides don't have to stay the same. They don't. All right, angle measurements have to remain the same. The sides do have something though. If you think back to what we learned in lesson 6.1, we learned that angles are congruent and the sides are, does anyone remember what that word was? Angles are congruent, corresponding angles are congruent, and corresponding sides are proportional. Okay, corresponding sides are proportional. So as we do this transformation, the measurements of the angles are going to stay the same, the measurements of the sides are going to change, but they're going to be proportional. All right, now there are two types of dilations. The first one is called an enlargement, and the second one is called a reduction. Okay, now this should hopefully make pretty easy sense. This one, it gets bigger. This one, it gets smaller. Okay, dilation is any movement. If you think about getting like your eyes dilated, if you've ever had to go to the doctor and get your eyes dilated, right, in that case your pupil gets bigger so they can see inside your eye better, so the doctor can look inside and see if there's any problems. But when we talk about your eyes dilating, we're checking, when light changes, do your eyes get smaller when the light's brighter? And when the light is dim, do your pupils get larger to let more light in? That's how our eye is designed to work. All right, so a dilation has the idea of it can enlarge, get bigger, or be a reduction, it can get smaller. Okay, a couple other terms. Image. Okay, the image is the shape after the dilation, or after just the transformation in general. In this lesson, it's after the dilation. Okay. The pre-image, that kind of gives it away. This is before the dilation or before the transformation. Okay. So pre-image comes first, image is second. Okay. So you need to make sure you know those two things. Okay, scale factor. Now we talked about this in lesson 6.1. First thing I want you to know is they usually use the letter K when they're talking about scale factor. Right, so if the book ever says find K, K isn't a variable like X or Y that we're solving for. It means find the scale factor. And keep in mind, it's always new over old. It's a fraction, and we reduce that fraction. If they don't give you which one is new and old, then they'll say something like find the scale factor from triangle ABC to triangle XYZ. You put ABC on top, so first one goes on top there. Okay, so if they say from ABC to XYZ, then we always put that on top. But if you know which one is new and old, you always put new over old. Okay, another way to say that would be image over pre-image. Okay, image, remember, is new, it's after. Okay, the pre-image is the old one, it's before. Okay, the last thing is the center of the dilation. The center of the dilation is a single point where the dilation kind of starts. That's probably the easiest way to say that. I'll describe this more when we get into some examples, and I'll show you what the center of dilation is. But you need to understand it's a single point. Okay. Okay, it's not, a segment or anything like that. It's just a single point. Like I said, I'll show you this more when we actually get into the examples. All right. So those are some terms you need to understand. Okay. Dilation, image, pre-image. Okay. And then scale factor and center of dilation. All right. That's it for the terms. Not real tough. Okay. Let's get into some examples. Okay. So the first one now. Copy these down as best you can. I know they're going to be a little bit difficult at times. Okay, But if you can copy something like this down, go ahead and do that real quick. Pause, because I'm going to keep moving here on the video, so you just pause it and then come back when you're ready to go. All right, so I've got this triangle here. I really have two triangles. I have triangle ABC and I have triangle ADE. They are similar to each other. I'm telling you they're similar. That's one of our givens in this case. And we're going to describe the dilation that maps just means moves, triangle ABC onto triangle ADE. Okay. Now, order is important still. Okay, ABC, ADE, that means this angle B, angle ABC, is congruent to angle D. It means angle ACB is congruent to angle E. Angle A is congruent to angle A. That works all the time by reflexive property. It tells me that side AC has to match up with side AE, AB with AD, and then BC with DE. Okay, all of those things that we talked about with similar shapes in lesson 6.1 still matter. Order is important, angles have to be congruent, sides have to be proportional. Okay, so as you describe a dilation, there's a couple things I want you to do. First off, I want you to tell me whether it's a reduction or an enlargement. Okay, so we're going from ABC to triangle ADE. So this is the new one, that's our image. This is our old one, this is our pre-image. Okay, so just by looking at it, I know this has to be an enlargement. Okay, now there's another way we're going to check to see if it's an enlargement here in a second. So we're going to write that down. It's an enlargement. Okay, secondly, I want you to tell me where the center of the dilation is. Now this one's pretty easy. All right, the center of the dilation, maybe one of the best ways to describe it, it's almost like a light bulb or a flashlight. Okay, so if I stick a flashlight right here at A, and the light starts to spread out as it goes. If you think about a flashlight, you know that light starts narrow and it gets wider as it goes, or car headlights or whatever. Okay, so if it shines the light onto segment BC, there's a shadow out here at DE, and the shadow is going to be bigger than the light in this case. Okay, because the light is coming from here and shining its way out. Okay, so A would be the center of my dilation for this one. Enlargement with A as the center of dilation. Okay. Usually if one shape is kind of tucked inside another one like this, all right, then it's pretty obvious that the point that doesn't change at all, that's the center of your dilation. The last thing we want to do is talk about K. So scale factor. K equals, okay, remember it's new image over old pre-image. So my new distance, the whole thing, not just the 6, CE is not a side of the triangle. So the whole thing is 14 over my old distance that matches with it is this 8. So 14 over 8. We reduce that if we can. In this case it reduces to 7 over 4. Now an easy way to check if this answer matches up with this answer, and I think we talked about this in lesson 6.1, but I'm gonna review with you just in case. If K is greater than 1, you have an enlargement. If K is smaller than 1, and by the way, K is always bigger than 0 because you can't go into the negatives for distances in geometry. So if K is between 0 and 1, then we have a reduction. If K is exactly 1, then that means the sides match up exactly. That means the sides are congruent. Then we don't really have similar shapes, we have congruent shapes. Now we can say that congruent shapes are similar. They're just kind of boring because the proportion is always just 1 to 1. Right? So we usually don't talk about that as being similar. All right? But technically they are. The angles are congruent. The sides are proportional. The sides are just in the proportion of 1 to 1, which isn't a very fun or very useful proportion to work with. So we don't really talk about K being equal to 1. Right? But that's a way to check your answer. So if you set this up backwards and get 8 over 14, and you're reducing it 4 over 7, and you know that's less than 1, but you put enlargement, something's wrong. You made a mistake. Go back, figure out where your mistake is, and fix it. All right? Okay, let's do this one. Okay, I got another example here. Okay, so once again, copy this down. All right, if you can copy it onto another sheet of paper as best you can. I have this very specifically drawn to help you find the center of dilation on this one. So you may not be able to draw it perfectly, but when we go to find the center of dilation, I want you to kind of follow along with the way I have it drawn here. To find K and to find out whether it's a reduction or enlargement, you're going to be able to do pretty easily, I think. All right, so here we go. Get that copied down, pause the video if you need to, and then come back. All right, so you should be ready now. So we're going to describe the dilation from WXZY. Now remember, when you name a shape, you can't just say WXYZ. You have to go around the outside in some order. So I said WX, I have to say ZY next. I can't just go alphabetical all the time. Okay, so WXZY matching up with GHJI. Once again, I can't say GHIJ. Okay, that doesn't wrap around the shape. It's kind of more like a zigzag pattern. Okay, so this is my old, my pre-image, this is my new, that's my image. So from here to here, it's getting bigger, right? That makes sense. So this is another enlargement. Okay, with something as my center of dilation. Now, it's not going to be any of the points here. So I'm going to show you how to find the center of the dilation with something as the center of dilation. Okay. And we can, in this case, we'll be able to name that point with whatever letter we want to use, that, as long as we haven't used it already. But let's find that scale factor real quick and make sure our answer of enlargement makes sense. So K equals, remember, new, so I have a distance here of 6. Okay, so that's new distance, over, I have a distance here of 2, and they match their corresponding sides, so I put 6 over 2. Reduce if I can to 3 over 1. Now if you want to write as 3, that's fine. If you want to leave as 3 over 1, that's okay as well in this case. So that's bigger than 1. Remember, back up here, if K is greater than 1, it's an enlargement. So that makes sense, an enlargement. All right, so now let me show you how to find the center of the dilation. So if you get something like this, especially if it's on a quiz or a test, you can just draw it. You might need a straight edge in this case to draw, and that's what I'm going to use. If it's in your book, you might need to copy it out, or they might actually have it drawn out. But what you do is you connect the points that match up. So G and W match up. So I'm going to connect G with W. And I'm going to kind of use dotted lines here, and then I'm just going to keep connecting them. All right, I'm going to keep kind of making it farther out here. You'll see why here in a little bit. So all I do is I keep drawing this out here. Okay, so like that. So that little dotted line connects G with W. Now I do the same thing with H and X, because those are vertices that match up. So I'm going to start with H. I'm going to start with X. Get that all lined up nicely. Okay, I'm going to draw a dotted line here as well. Okay, and I'm going to keep doing this for all 4 corners. Okay. If it was a triangle, I would do it 3 times because I would have 3 corners. Okay. All right, so now I'm going to do I. I'm going to do that with Y. Hey, that rhymes. I with Y. I'm a poet. I don't even know it. Some of you might like that humor. Some of you probably hate that humor. Sorry. Get over it. All right, and one more. I got to go with J and Z. JZ. All right. Couple years from now, no one will even know who he is. All right, JZ, connecting that as well. Now, what you'll notice by the time we finish this is all 4 of those dotted lines, they end up intersecting right here at this point. That point is the center of the dilation. And you can almost picture this. Once again, remember, if this was like a flashlight here, and I was holding this little piece of cardboard or something right here, this would be the shadow out here. So I'm like projecting it out. Okay? So that center of light is kind of like the center of the dilation. So a flashlight shines onto this, produces a shadow that comes out here. So now I can call that whatever point I want. I already used W, X, Y, and Z. I used G, H, I, and J, so I can't use any of that, so I'll just call it Q. All right, so that means down here, when I describe it, I'm going to say Q is the center of my dilation. All right, so that's how you find the center of the dilation. Now in your book, sometimes they'll have that drawn out for you already. Let me show you a quick picture in your book, okay? So right here, see this? O would be the center of the dilation. X, A connects down to O, Y, B connects to O, Z, C connects to O, so they already have it drawn, so O is the center of the dilation in that case. All right? So you'll see stuff like that in your homework. All right, let's do one more. Okay, so we're going to describe the transformation. Now this time I didn't say dilation because it's more than one. This is a composition, so we got to do a little bit more than just say, hey, it's an enlargement. It's a little bit more than that. Describe the transformation that maps PQR, that's my first one, onto STU, my last one. Now once again, order is important, so I said PQR. I matched that up with STU. You'll see how the angles are matching. Hopefully you can kind of see how that works. So copy this into your paper real quick. Once again, best you can. It may not be perfect, especially when you go to find that center of dilation. All right, but copy it down the best you can, and then I'm going to throw some numbers on here too to help us find the scale factor K. All right, so pause if you need to. All right, in the meantime, I'm going to get some numbers on here, and we're going to go from there. All right. All right, here we go. So, first off, new is way up here, okay? I should put a 2 over here as well, just so to help you out, okay? New, old. So, it definitely looks like it's getting smaller. We'll be able to check that when we find K. So, let's talk about smaller, but we got a few things going on. It got smaller here, and then it went there. So, we got 2 things going on. So, first off, let's talk smaller. So, it's a reduction. All right, with, and we'll leave a blank there again, as the center of dilation. We'll find that center here in a second. Okay, so from here to here is a reduction. Let's go ahead and find that center of dilation. So let me get my pencil out again. All right, I'm going to draw these. This time I'm going to draw a straight line instead of dotted lines. It just goes a little faster. So if I can draw a straight line without doing all the dotted stuff. So I'm just going to draw that. All right, now I'm going to connect from here to here. All right, and then I'm going to connect from here to here. Get that to go right. Okay, so right here is the center of my dilation. Okay, we've already used A and B and C. We've used PQR, STU, used a bunch of letters, so I'll just call this V. Okay, so V is the center of my dilation. So from here to here is a reduction. Now, how did I get from ABC over to STU? Well, you'll notice the sides match up. So they're the same, so that's congruent. So this is one of the old things we learned. So it's a reduction with V as the center of dilation, and then, what is this? If I go from here to here, is it a slide? Is it a rotation? Remember, slide is called a translation. Is it a rotation or is it a flip, a reflection? Well, if you're looking at it, it should be pretty easy to tell by the angles that it's a reflection. A reflection in a what? Remember, reflections always happen in lines. So what kind of line would that be? Looks like it's in a vertical line. Okay, and I could find that vertical line if I really wanted to. I'd measure the distance here and wherever the midpoint is there, and I'd measure the distance there and find that midpoint, and I'd connect them. I'm not going to do all the measuring. I'm just going to kind of draw a rough sketch of it real quick, but basically we've got that kind of vertical line. Okay, so that's what's going on here. So we got a lot going on. So I got my reduction, I found the center of the dilation, then I reflected it, all right, in a vertical line. All right, now last thing we need is K, a scale factor. So K equals, remember, new image, this is my final image, 2 over my old, my pre-image. That matching side is a 4. That reduces to 1/2. Remember, if K is between 0 and 1, it's a reduction. So that makes sense. All right. Last one, I don't have this drawn, so I'm going to just draw a real rough sketch of it. Sometimes you get ones where the center of dilation is kind of in a unique spot. So let me draw just a real rough sketch of that real quick so you get something like this. All right. And then maybe our other one is something like this. Okay, now if I start to connect the corners, okay, I don't know that this is going to happen perfectly. Probably not, because I didn't draw it to scale very well. Now we're just going to go with, I'm just going to do 2 of them. Okay, you do something like that. And then you do something like that. Now if I were to do all 4, I don't think it would work very well because I didn't measure this stuff out like I should have. But in this case, the center of dilation, sorry, out of the picture, the center of dilation would be right here. It can be inside the shape. Here we had it outside, remember, like I was talking, like with the flashlight projecting this onto a shadow. In this case though, the shadow was the beginning point and this was our newer one, right? But in this case, the light's almost like coming from the inside and coming out. That can happen. It just depends on what it looks like. But once again, if you just connect the corners wherever they meet, and it has to be all four, all right, this one, if you can see, if I connect this, it's not going to hit over here. So that means these technically are not similar shapes, right? And that's because I just freehanded it really quick. I didn't get my ruler out and measure it, right? But this would be the center of my dilation. It's the same idea. You're just connecting corners, but it can be inside the shape is what I want you to understand. You're going to see one like that, I think somewhere in your homework. Let me see if I can find a quick picture of it. Yeah. So let me show you a quick picture. All right. Book's kind of in the way. Here we go. Can you see it? Right up there, number 3. All right, see how that center dilation's inside? That's fine. That can happen. Okay. All right. That's it for lesson 6.2. If you got questions, make sure you ask them when you come to class. All right. We'll see you guys in class.